So we can move this code and then or started refactoring, because we could take two approaches. Let's say get certain functionality from here and then add functions here in main, and then let's say decide to move somewhere else, or just move everything to different package and then just to have the entry point for this.
Yeah, I see what you mean. Whatever features we add or refactoring we do, some of it will be here, so it's going to have to move anyway. So we may as well just move it, and then we've got a solid base to work from. And I think that's right. And this is another decision point that everybody faces, isn't it? If they do this main-driven development thing, which I recommend, I find it helpful. If purist TDD would basically be you literally write a test, the first thing you do. But that's really hard for reasons we've discussed, because you may not even have it clear in your mind exactly what the program's going to do, so you can hardly test it. So what I do is just play. I just open a main.go and just start playing, trying to do something. Once I have an approach which I think is basically going to work, now I can figure out what's the name of the package going to be, what would the name of the methods be. Of course all that stuff's going to change anyway, but I'm closer to it. And the question is when? When should you do that? It's not always easy to know, is it?
Yes, so this is a good question, because you can grow your main till, let's say, thousands of lines of code, and it still works, right?
Yeah.
But it's a danger that at some point you will need to get to other project and you won't have time to refactor this.
Yeah, that's right. I mean, a project I'm
That's like
consulting
a real life, yeah.
Yeah, absolutely. This is very much drawn from my life, because a project I'm consulting on, they have exactly this. They have about 200 lines of main.go, and it's full of business logic. It's doing all sorts of stuff. I mean, there are other packages, and main is calling into them. And the thing is, they're sort of okay with it, because they're the only ones who use this program. It's not some general purpose library that's on GitHub for people to use because they couldn't. But but they sort of say, well, when we build the program, it works. Just like you said. So what's the problem, sort of thing. And I'm sometimes a bit stumped for an answer to that, except I just have to say, well, I just like small mains. But I do think it's a really useful design principle to always write a library, even if what you're writing is actually a command line tool. Just put all the business logic in a library, and then the CLI is just a trivial wrap around it. As you've pointed out, that means someone could use all of your business logic just with a different front end, web or whatever. And it also means, you force yourself to design a sensible API, don't you? You can't just reach in and tweak all the knobs and levers yourself, because now you have to import some package and you have to call its exported methods and refer to its exported types.
And this automatically actually makes you to think about your API of your package. So this all exported functions, right?
Yeah, exactly. And, it imposes some discipline on you, but, discipline can be a great thing. I mean, not everybody likes it, because they say, well, I don't want, I don't want to have to endure this discipline. But that's, I think, the more humble approach is to say, well, I recognize that I'm extremely fallible. I'm making mistakes constantly. Actually, I want to impose a discipline on myself because I don't think I'm always going to get it right? And, in some sense, forcing yourself to jump through these hoops is probably going to create a better architecture, cleaner, more decoupled architecture that you can understand and other people can understand better, so it's more maintainable. And people might also want to use your library. This is sort of before the world of GitHub, I never really thought like this. And any time I wrote a program, it was basically for my own amusement or for my company or whatever. Never really thought about other people using my code without my knowledge. What do you think? Did you have some point in your career where you suddenly switched to thinking of yourself as a library writer?
Couple of years ago, because mainly I was before actually GitHub, I was writing, certain smaller programs either for myself, some stuff back then on ZX Spectrum years ago, or later on, or Atari and PCs, mainly for myself, or some calculations for university. And later on at work, mainly these programs were for basically the projects that we were working on. So I was dealing a lot with hardware. So was like a mix of electronics and software development. But later on, when GitHub actually started and this potential number of users of your libraries actually grows almost till countless number of people. You are not limited only, let's say, to a couple of colleagues from your work.
Yeah.
It makes you actually think more about the engineering and possibility that other people will be using this library, for example. And in general, what I see is, I would say that many open source projects are much better in terms of reliability and the code quality than the internal projects.
Right. It's the many eyeballs theory, isn't it? The more people are sort of using and working with this code, the more bugs they'll catch, and the more they'll improve it generally.
Yeah. And many times, for example, I smile myself when I do a code review or colleagues reviewing my code, and we are laughing, telling that it wouldn't be allowed this kind of change if we were open source.
Right.
Yeah.
Yeah, very much so. So yeah, okay, let's try and do this then. So let's think about how to move more of this over there.
To Lander, right?
Yeah.
Or are we creating some other? Okay, so let's open our Lander. So we have here the part that we are dealing with, the creating the new game, and I would start with some method. Let's say that we could take out the logic from here and put this into, I don't know, separate like a run method or play game, something.
Yeah, well,
like that.
suppose what we did was we kind of took little units which seemed to be reasonably separate from everything else and moved those, and then refactored main to just call them. So originally we just printed out the state, then we refactored that to be g.displayState, and we can continue that, can't we? And maybe there just isn't anything left other than run game, but maybe there is. So you could say, like, maybe detect landing might be one, this if statement at line 22, for example.
Let's switch to main.
So we have now exited the main game loop, which, by the way, keeps looping as long as the altitude is greater than 0. So as long as you're still above the ground, the game is running. The minute you touch the ground, that's it, it's over. And all we do is just say, well, how hard did you hit?
Mm-hmm. So it's basically we could extract this code. Let's copy at this moment.
Yeah, well, suppose we started with a test.
Yeah.
That ought to be possible, oughtn't
it? Makes sense, yeah.
We're saying there would be some function in Lander that we're calling, so what is it that we want to move? Do you want to just have... Suppose we think about the landing. A method on the G would make sense, wouldn't it?
Yeah, so just these lines here. So, right, then increase the velocity, and then so will be this one method, and then we could get and the lander tests. So whatever name of this, what you suggested, what name for this? Land? Yeah.
Well, let's suppose I like to quote this Zen saying, you know, if you want to climb a mountain, begin at the top. So I like to always assume that I've already written the function in question, and then I just want to call it. And then the way I call it is going to tell me a lot about what its name should be, what it should take, and what it returns. So suppose we did that in main. Let's just comment out that lines 23 through, 27. If we comment out those for a moment and just say, well, what would we like to write instead? We have the G.
Yeah,
we can call something on G, and we want to know, well, again, the way I like to frame tests myself is I think about what's the behavior that I want to test here. So the behavior is, if the velocity is less than 10, then show the user a safe landing message, success. Else, show them a crash message, try again. So that's something we could test, isn't it?
Mm-hmm.
We already test methods which print messages to the user, for example, or print to the user and read their input. So we could look at, so display state is one of those. So we could look at test display state, and we could say, well, it's very similar to that, except we just display the game result, isn't it?
So maybe display result or result, game result, display result.
Yeah, that sounds fine. So
display result, yeah.
So copy and paste School of Programming, we can actually take that whole test, can't we, and just...
Then we will.
And this is another great consequence of the fact all the tests are the same. You know, it's very, very easy to copy them. Yeah,
okay, like here we have exactly the same situation. Want we will have different.
Yeah, actually there's two cases, isn't there? Or at least two cases.
So we have either we are landing safely or unfortunately not.
Yeah, so suppose we named the test something like test landing test soft landing displays success result, something like that. And then so you can have a corresponding one saying test hard landing displays failure.
Okay, so what would be your approach? Are we adding, for example, underscore and then condition of our tests, or just changing this?
I just write it in normal camel case. And
okay.
Normally, I don't like to write super long function names, but I do with tests, because the nice thing is when the test fails, we'll see the name of the test function printed out, and that will actually tell us everything. It'll tell us what's not happening, isn't it?
Mm-hmm.
So we could say something like test soft landing displays success result. How about that?
Soft landing. Something like this, yeah.
Yeah, but the behavior is that it should show you a success result if it's less than 10, or a failure result if it's 10 or more.
Okay, but test display results soft landing.
So we want some way to say something like success result rather than... Yeah, that's okay, but we don't really need an underscore, do we? We can just use camel case. Yeah, I think this will do.
Okay.
Add that to the bike shedding list.
Success, yeah. Now, success result we will get when we have the MATLAB's G state velocity. Okay, so what we need to do right now, we have, okay, what we want.
Yeah, what do we want? That's
yeah.
You could almost have a little card sort of propped up by your machine, couldn't you, for writing tests. It's like, what behavior do I want to test? What's my want? Yeah,
Yeah,
by the time you've solved those two problems, you've basically done it all, haven't you?
yeah, exactly. So we want some number that is basically less or equal 10, right?
Yeah, well, we want
To
that
this
message,
condition.
say,
Yeah.
safe landing, something in brackets, you win. So we can copy
Okay.
that. And
Yeah,
the thing
that
is,
makes sense.
we can set whatever velocity we want on the G. So
That's
we'll
true.
just set
Yeah.
something.
Okay. So basically, we want
And let's say it's exactly
set
what, 9.0,
landing.
let's say.
Let's say that. Velocity.
So we can just hard code the entire string, can't we? Because we know exactly what it will
Exactly.
be.
Yeah.
This goes away. And we can just substitute in 9.0 meters per second, let's say, to pick a number at random.
Per second.
Yeah, there's no percent and no F because it's just a string literal.
Like this, safe landing.
Great.
So we want this kind of message. Okay.
And we still want this buffer so that we can have something to print to.
So this stays the same, display state instead of display state. We want to have actually display the result.
Yeah. Works for me.
Result. All right, we don't have this function yet, so it's natural that we see this underscore here. And
yeah, I really think it's a shame that it sort of displays an angry red line. You know, even though you're doing everything right, I think it should pop up something saying, "Hey, it looks like you're doing TDD. Great job. Keep it up," sort of thing.
We could open feature requests for the developers of VS Code.
Yeah, actually, you know what would be really neat is like it's obvious from this that there should be a display result method and exactly what its signature is. So the IDE could just add it for you, couldn't it?
Yeah.
Yeah, why can't they do that?
So we have display result. We actually expect this string, and then basically we need to compare if what is what we got.
Yep, that's all standard. So we can certainly write a null implementation of display result, can't we? Just don't do anything because we want to see the test fail.
Yeah, so shall we run this test right now or start going
yeah, well,
implementing some?
We should see it fail to compile right now, and we know exactly what the compilation failure should be. It should be display result undefined, something like that, shouldn't it? So we can just check that. Because maybe we made other compile errors in the test. I mean, I do that all the time.
Yeah. We open terminal here. Let's have a look on this test here. Okay, so we are here, Lander project, and let's go run, go test. And we have information.
Yep, happy with that. That's what we expected.
We don't have display result methods, so let's fix this first. In our case, we need to come back to Lander. And
the nice thing is there's no thinking required at all here, is there? The test already mandates everything that we're going to write now.
Yeah.
What I used to do when programming is sort of think, right, I need this function, you know, sit down, I'll write func, and then I'll sort of stop and say, well, I don't know what its name should be. And that's a major red flag. And if I know what its name should be, I'm not sure what arguments it should take and so forth. And I could guess, of course, but I'm almost bound to be wrong. So what that's really telling me is I should actually just go and write some code that calls this function. A test would be ideal. And then I'm making those same decisions, but I'm making them in the right context, aren't I?
Yeah. So we have test code here for our display result, right, with success, and we need to right now implement this.
So the test is telling us that the display result is a method on the G, So we can do that bit, and we can ask ourselves, is it a pointer to the G or is it just the value?
Yeah. So let's have a look. Let's implement this. So we are displaying, so we are not changing state, right?
That's right. So we can apply this thinking tool to say, is the purpose of this method to modify the G? Because if it is, we need a pointer. It isn't, so we don't. Easy.
Display result. Okay. Let's take similar approach and use IO writer.
Yeah, same API as display state, isn't it? Which is
now
nice.
we are at the point that we have implemented function, right? So we have implemented function, and I would say if we run the test again, let's have a look how.
Yeah, it doesn't return anything.
Looks like. Yeah.
So this should be enough to fail. And we know what the failure should be, don't we?
Yeah.
It should be something like want, success message, got, empty string.
Yeah.
I assume. We didn't write anything to that buffer, so that's what its contents will be. Yeah?
And let's run this test.
Wow, I can predict the future. That's incredible, isn't it?